Hello, welcome back. My god, lots of emails. Okay, so welcome back. So we looked at the basic rules of differentiation and we talked about the few combinations. So, like, what if there's some function plus another function and you want to differentiate it, right? We talked about what in the case where there's a multiply sign in between, in which case we would apply the product rule, right? We talked about what if there would be a divide sign or a minus sign. And so one type of combination that we are left it with is the combination of composite functions. So what if I want to differentiate something like f g of x, right? And before I start, if you don't already know the idea behind composite functions, I encourage that you watch out the video that I made about composite functions or get an idea about how composite functions are. Just to brief you on it, if there's some function, let's say sine x, and there's another function x squared, then f g of what's my stylus doing, then f g of x would be sine x squared. And what this means intuitively would be that, say if you have some number line 1 2 3, let's say this is some input x, what f g of x means is that that input first goes through g of x, right? So let's say it gives some value over here and then it goes through f of x, right? So when you put this certain input, f g of x directly takes you over here, f g of x, right? So the first rule that we'll talk about is called the chain rule, and it uses the idea behind how composite functions work to make some of the calculations easier. So let's say there is something like y equals 4x cubed plus 3x to the power 5, right? And our end goal would be to find the differential of this, right? So the first thing that I will do is I will split this into two functions. F of x, the outer function will be x to the power 5 and the inner function will be whatever is in the bracket, which will be x to the 4 plus 3x, right? So let's draw three lines over here. And what f g of x, okay, so f g of x would be x to the power 4 plus 3x all raised to the power 5, right? So what f g of x means is that, say when x is 1, this is our input, so when x is 1, that x first goes through g of x. So after we input, so 1 to the power 4 plus 3 times 1 would give us 4. It lands at 4. And then this function fg of x would take that 4 and plug it into f. Right? So it would give you the value 4 to the power 5. So the question that we want to answer is the following, right? Say there's some slider over here and you change that slider by some dx amount, right? What we want to calculate is by introducing that certain dx, what is the change in our output, i.e. what is the change in f g of x, right? So our end goal is finding the derivative essentially, and which would be, I was writing correct the first time, f g of x over dx, right? Remembering that the question is essentially when you introduce some small change in x, what is the change in the final output. So what chain rule does, it uses a clever idea that instead of trying to do it directly, what you could do is you could split it up into these two steps, that is from here to here and then from there to there. What chain rule does, it first asks the question that when you introduce that certain change in x, let's take a different color. When you introduce that certain change in x, first of all, what is the change in the intermediate state? What is the change in g of x, right? So it asks when you change x by some small amount dx, what is the change in g of x? Because essentially that g of x is then taken in by f of x. So it first we first ask the question that from here to here what is the rate of change, and then we ask the question that for some change in g of x what is the change in fg of x, right? Asking the question that when we introduce some change over here, what is the change over here, right? So just writing in verse what I have just said, the first thing that chain rule asks is, okay, let's write this, let's change this color to red so that you can see. So first it asks the question, what is the change in g of x over the change in x? And the second question it asks what is the change in fg of x? I keep writing gf of x. What is the change in fg of x as you change g of x a bit, right? So just moving on to some calculations. G of x, this one would be pretty simple. We know that the differential of x to the 4 plus 3x over dx would be 4x cube plus 3, right? This is just simple power rule. Let's come to this one. It is asking the question, what is the change in x to the power 4 plus 3x squared to the power 5? So essentially the same equation. But this time we ask the question, what is its change in terms of g of x, right? In terms of x to the power 5. Oh, yeah, in terms of x to the power 4 plus 3x. Right, instead of our original question where we asked in terms of x, right? So the first thing that you need to realize is that, say if I take something like what is the differential of x to the power 5 in terms of x, you would quickly say 5x to the power 4, right? Because that's how you differentiate x to the power 5. So in over here I was introducing some change in x, and I was finding the differential I was finding the change in x to the power 5. Here I am introducing some change in x to the power 4 plus 3x, and I am asking what is the change in x to the power 4 plus 3x to the power 5. So it's essentially the same question in the sense that this would also give 5 multiplied by x to the power 4 plus 3x to the power 4, right? And the reason behind it is that over here we are taking it in terms of g of x, right? So you can think of this thing, lot of emails, you can think of this thing as simply your x, right? So if I am differentiating something like f g of x in terms of g of x, you can, if it helps you computationally, you can just think of it both of these x as x, because essentially you're changing g of x by some amount, and and this would be the same as f of x over in terms of x. Computationally this would be the same, not really, like if you take out the answer you can clearly see these two are different, but the basic idea is the same, that you can treat this as your input x. You can treat this because you are asking the question in terms of g of x, right? So that's why you can do the following, right? So what we have over here is, a, we know how much g of x changed with some change in x, and what we also know is how much, okay, let me write this over here, we know how much f g of x changed with some change in x, with some change in g of x, and we also know how g of x changed with some change in x, right? Just putting in the numbers, this is what it looks like, 3x to the power 5 in terms of x to the power 4 plus 3x, and we also know how much was the change in x to the power 4 plus 3x in terms of x, right? So what you would realize is that since these two are linked together, when you multiply this, this numerator and this denominator would cancel to give you the same question that we asked previously, that is, what is the change in f g of x in terms of x. What we just did is that we split it into two, first asking the question what was the change in terms of g of x, and then we asked what was the change of g of x in terms of x. So when you multiply them, it essentially gives you the same question that you asked, that we asked before. Similarly, if you multiply here, this thing would cancel this thing, and so it would give us the change in x to the power 4 plus 3x to the power 5 over dx. And the reason we did this is that, okay, now we know what this value is, we also know what this value is, so we can essentially multiply them to get our desired answer, that was the differential. So we got, what we got was 4x plus 3, so 4x cube plus 3 over here, and this should multiply with 5 times 5 times x to the power 4 plus 3x to the power 4, and this is your answer, right? So knowing the big picture behind how composite function, how chain rule works, using how composite function work is pretty important. And if you just want a computational shorthand, you can remember that for any, let's say for any f of x to the power n, its differential would be n times f of x to the power n minus 1 multiplied by the differential of f of x, right? A lot of the people remember it as the applying the power rule and then taking the differential of the inside, right? So in this case, I took some example where the outer function was x to some power n, but the concept of chain rule would work any time where you can break the function into two separate functions, right? And also note that how the name chain rule corresponds with its explanation, that how you can link up different things, how you can break up different things that are linked together, right? So now we come to a subtopic that where a lot of people start to find the use of calculus, right? It's called related rates. And the reason why some people find this section to be the section where they find the use of calculus, because this section has a lot of real life situations. So for example, if I have a cylinder right over here, and let me draw this and this, let's say the cylinder is of radius 2 and is of height 10, and there's some pipe over here that is pouring the water into this at a constant rate of, let's say, 2 meters cube per second, right? So when 1 second has passed, there would be 2 meters cube of water over here, then it would keep on increasing, right? And what we essentially want is, we want to know the rate at which this height is increasing, right? So when we pour water, the volume is constantly increasing, and with that increase in volume, there's some increase in height, right? So our question is, what is the rate at which height is changing? So if I call my h height, my v volume, and r is of course the radius. So the question that we are asking is, what is dh dt? What is the change in height over change in time, right? And just converting this into a format that we already know, this is change in volume over change in time, and it is equal to 2. It is constantly equal to 2 at all values, right? So the way we do it, this is sort of related to the explanation of chain rule too. So we know the first thing that we would have to do is connect this change in volume to this change in height, right? We would want volume in terms of height somehow. So we know that volume is pi r square h, and whenever if you take the volume at any instant, we know that the radius is constantly 2, the only thing that is changing is the height. So we know that volume at any point is pi 2 squared times h. We know volume at any time is 4 pi h, right? So at any instant, if I plug in my h, it will give me my v, right? So I got to know what is v in terms of h. V is a function of h. Now what I will do is, I will find the change of volume as I change my h. So I will find dv dh, right? Change in volume as I change my h a bit. So this will be 4 pi, right? H has the power 1, you just apply the power rule and you get the answer that dv dh is 4 pi, right? Which essentially means that for some small change in h, the change in volume would be 4 pi. Why did I did this? So essentially, let's write these over here: dv dh dv dt and dh dt. Right, let's write this over here just because. Okay, so let's write this over here. Right, so what you would realize is that when I multiply these two, this is equal to this, right? So the change in volume in terms of h multiplied with the change in h in terms of t would give you dv dt, right? And this corresponds with our explanation of chain rule, why this would be true, right? And so I know what this value is, I know what this value is, and I just need to find this, right? So dvdh is 4 pi, 4 pi times the thing we asked initially, and dvdt is constantly at 2. So dh dt would be 2 over 4 pi, which is 1 over 2 pi, and this is our answer. So essentially, by linking volume to height, and then by connecting them like this, we got to know the rate at which height changes. Given that we already knew the rate at which volume is changing, we got to know the rate at which height is changing, essentially because volume and height in this case were directly linked, right? So that's it for today, and yeah, bye bye.